Hello and a really big warm welcome to this presentation from the Urban Penguin. My name is Andrew Mallett and today we're starting on topic 1.4 of our Python Certified Entry-Level Programmer. This is all about choosing the correct operator and we're looking at our numeric operators for the moment. Now of course some of them are going to be really simple, such as our addition operator. We also have our subtraction operator, our multiplication operator, and our division operator. And of course, as I say, these are relatively simple, and we're probably reasonably used to these. But as well as these, we have other operators, such as our double asterisk. And when we look at this is our exponentiation operator. So 2 to the power of 3, which is the same as 2 multiplied by 2 multiplied by 2, and that's going to give us 8. We also have our modulo operator, which is remainder division. So 7 modulo 2, 7 modulo divide by 2, gives us 3 remainder 1, so the answer is going to be 1. Almost the reverse of that is our floor division, the double slash. With this, 7 floor divided by 2 gives us 3, where we only take the full or real number. Our brackets can control the evaluation order, and we're going to take a look at the evaluation order in the next slide. But the big thing to take away from this is that you may need to recognize the result of an evaluation in the exam. They might give you several evaluations and say which one would give you the answer 6 as an example. When we look at the all-important evaluation order, the way that we write things from left to right is not necessarily going to be the order of evaluation when we look at the science of mathematics. There are a set of rules to govern the evaluation order. So when we look at something like this, we might have written it as 4 minus 3 multiplied by 2. But the multiplication is going to happen before the subtraction. So it becomes 3 multiplied by 2, giving us 6. And then 4 minus 6, which gives the result of minus 2. If we want to control the evaluation order, we can put in the brackets or parentheses. So this now does become 4 minus 3, which is 1. 1 multiplied by 2 gives us 2. If we want to clarify the evaluation order, even though it might not change the evaluation order, we can still use the parentheses. So here we can see that we've got 4 minus 3 multiplied by 2 inside of our parentheses, highlighting the multiplication is going to happen first. The order of evaluation can be shown through PEMDAS, where we evaluate the parentheses first, the exponents, multiplication, division, addition, and subtraction. However, when we look at multiplication and division, which includes multiplication, division, floor division, and modulo, if they appear at the same level, then they're evaluated from left to right. And that goes as well with addition and subtraction. So they are a separate grouping appearing after multiplication and division, but if they appear at the same level, then they are read from left to right. We can see this as an example. 2 minus 1 plus 3. So we read from left to right exactly as we have written this. So the answer is going to be 4. But in the same way, as we mix the addition and subtraction around, we've got 4 plus 3. That is evaluated first, reading from left to right, and then 3 minus 2. So we get 5. When we look at our multiplication and division, if division occurs first at the same level, it will be evaluated first. So 4 divided by 2 multiplied by 5 is going to be 10. Whereas we have our multiplication first, well, reading from left to right, we will evaluate that first. So 5 multiplied by 2 divided by 5 gives us 2. The only other thing to take real note of is that our exponents are right associated. So if I have two exponents at the same level, then they're read from right to left. So if we have 2 to the power 3 to the power 3, we evaluate this as 3 to the power 3, which then gives us 27. And then 2 to the power 27 gives us this very large number. If we want to control the order, we can go 2 to the power 3. So that gives us 8 to the power 3 gives us 512. We can also take a look at our assignment operator, and of course that's the simple single equals symbol. So we can assign the variable x with a value of 5. But we also have shortcut operators. So x plus equals 3 is the same as x equals x plus 3. X minus equals 1 is the same as x equals x minus 1. X multiplied equals 3 is the same as x equals x multiplied by 3. X divided equals 2 is the same as x equals x divided by 2. And modulo assign x modulo equals 3 is the same as x equals x modulo 3. Same as our floor division. So x equals x floor divided by 2. And when we look at our exponentiation and assign, we can go x exponent equals 2 is the same as x equals x to the exponent 2. We can work through an example of this. Here we can look at decrementing or reducing the value of a counter. So we can set up our variable count with a value of 10 using the assignment operator. Our variable name is well chosen here, so throughout our code we should have a good idea of what the variable's purpose is. We've now got a while loop. We evaluate the value of count, and whilst it's greater than 0, we will then execute the code in the block. The code block is indicated by the colon at the end of the line. We've now got our print statement where we can print the value of count, so we can see its current value. But notice there's something slightly different with print here. We've put end equals and then a space. Normally, at the end of a print statement, we will add in a new line. We're overwriting this with a space, so that all of the values of count will be on the same line, separated by a space. Now, if we executed the code at this stage, it will keep on executing because we're not changing the value of count. So here, inside of our block, we can go through and make sure that we reduce the count by 1. So count minus equals 1. Each iteration, we're going to be removing 1 from its current value. So we're going to begin on 10 and then go through 9, 8, 7, 6, and so forth. Now, as always, the very best way to understand this is by you getting some practical, hands-on experience. So why don't you join me as we open up our Jupyter Notebook to be able to understand how all of this really goes together. So look at this, our glorious Jupyter Notebook. And the Jupyter Notebook, well, we're going to get that valuable hands-on experience working with our numeric operators. So let's begin with some of those very simple operators, those operators that we know. So we could do something like 1 plus 2, hit the shift and enter, and we can see then that that will evaluate through to 3. As we continue with our simple operators, we can look at, say, 5, subtract 2, and that also equals 3. If we look at 5 divided by 3, we've got 1.6. And maybe if we look at 5 multiplied by 3, then we're going to get 15 as the evaluated result. And as I say, these are our simple operators that we're probably very familiar with. But we also have some of our more scientific notation. So if we look at 2 to the power of 3, that's 2 multiplied by 2 multiplied by 2. And when we look at the result, that comes back as 8. And when we look at remainder division, so 5 modulo 3, 5 divided by 3, and looking at the remainder, 5 divided by 3, well, we have 1 remainder 2, so we print the remainder value of 2. As we talked about, really the reverse of this is our floor division. So if we do 5 floor divided by 2, we get the result 2. There are 2 2's in 5, and we don't care about the remainder at this stage. So next up, we have to look at the order of evaluation. If I look at 2 minus 1 multiplied by 4, even though we've written it from left to right with the minus being first, the priority is on the multiplication. Multiplication comes before our subtraction. So when we look at the evaluated result, we get minus 2. 1 multiplied by 4 is 4. 2 minus 4 is then minus 2. If we put in our parentheses then are evaluated first. So now we get 2 minus 1, which is 1, multiplied by 4, which is going to be equal to 4. The rules that govern this are PEDMAS. So we have P for our parentheses, E for our exponents, D and M for our division and multiplication, and A and S for our addition and subtraction. I'm going to put D and M together and A and S together because they are said to be groups. Where we have division and multiplication on the same level, then they're going to be processed from left to right. There's no priority. The same as addition and subtraction. If they're at the same level, then there is no priority. We can see this by doing 3 divided by 1 multiplied by 4. We just read it from left to right because division and multiplication are at the same level here. So we get 3 divided by 1, which is 3, multiplied by 4, and we should evaluate to 12. When we look at putting our multiplication first, then we're going to see, again, multiplication and division are in the same group. So 3 multiplied by 1, divided by 4. When we look at evaluating the result, now we've got 3 multiplied by 1, which is 3, divided by 4, that gives us 0.75. This works as well with our addition and subtraction. So if addition and subtraction are at the same level, then there is no priority, and they're read from left to right. So 4 plus 1 minus 2, so that's going to be 5 minus 2, which is going to give us 3. And if we look at doing 4 minus 1 plus 2, we then get 3 plus 2, which is going to evaluate to 5. The only thing that behaves slightly differently is when we look at our exponents. If we have 2 or more exponents at the same level, then they're going to read in the reverse direction from right to left. So if we look at 2 to the power 2 to the power 3, we read from right to left. So first of all, we do 2 to the power 3. So that's going to result in 8. We then go to the left and see 2 to the power 8 now, and that is going to give us a result of 256. Having looked at our arithmetic operators, we can now move on to our assignment operators. And of course, the simplest of these is the single equals sign, where we can say the variable x is assigned the value of 5. So when we look at x, we can see, of course, it has that value of 5. But we also have shortcut assignments, where we can then change the value at the same time. So if we go plus equals 1, we're adding 1 to the current value of x. So this is going to take us from 5 through to 6. So if we now interrogate the variable x, we can see that we've got a value of 6. Similarly, we can work with x and use minus equals and then 1. So we're subtracting 1 from the current value of the variable x and reassigning it. So as we then look at the value of x now, we're back to the value of 5. From the slides, we were able to see a simple demonstration, but let's go through and set up that demonstration. So if we use count equals 10, so we're assigning 10 to our variable count, and again, a really well-named variable, so we're understanding how this works. With that set, we can enter our while loop. We can look at the value of count, and if it's greater than 0, we can enter our block of code. We can see that we get indented automatically when I hit the return, and we can go into our print statement. And so far, what we've seen with our print function is we're used to it like this, where we just print out our variable or our text. But we can extend this a little bit. A normal print function is going to put a carriage return, a line feed at the end of the print statement. But we can choose the end character that we want to use. So we can use end equals, and we're just going to add in a space. So we're going to see all of the results on the same line. Now, if I executed the code at this point, we're not changing the count variable, so we're just going to keep incrementing through the loop. So we're going to then reduce the value of our count. We can reduce it by 1, but we could reduce it by more, so don't get stuck by the idea that we have to reduce by 1. But now we're reducing the counter by 1, so we've given a logical end to our looping structure. As we look at the output, we can see then it's all on one line, separated by the ending space, and we've got the correct values then printing out. If I take out the end, and if I try executing the code at the moment, we might think, well, this is strange, why isn't it printing? Well, our count variable has been changed to 0, and we haven't reset it. So we can go back to line 21 in my case, re-execute the counter to have a value of 10, and then re-execute my while loop. And you can see why we chose the ending to be a space, because we probably don't need it on separate lines. So we can go through and put our ending back in place now. And again, to show that we don't need to be stuck by decrementing by 1, we can subtract 2 as we loop around. Set our counter back, execute our loop again, and you can see now that we go 10, 8, 6, 4, 2. If we want to take a look at an example of where we might use modulo division or our remainder division, we can run through a for loop. Here we're using for I. I as a single character works here because we're representing I just to be an integer. That integer needs to be in our range, stopping at the value 10. So it's going to be 0 through to 9. As we then go through into our for loop, we can test the value of I. So if we look at if I modulo 2, I divided by 2, and if that then doesn't give us any left over, so if it equals 0, then we're working with an even number. So remember, this is our remainder division. So if we don't have any remainder, it must be an even number that we're working with. So we can have a little print statement. We're going to use format printing so we can include our variable. Our variable just needs to be in the brace brackets. So our variable I is an even number. We can close off our quotes, close off our parentheses, the round brackets, and we can move back to line up with our if statement now. So we can put in the word else followed by the colon. We don't need a condition with else because we're saying if anything else occurs, but we do need our block of code. And of course, we're then going to be printing that I is an odd number. We're either going to be an even number or an odd number. The remainder division with the modulo is going to be able to identify by the remainder whether we're odd or whether we're even. Let's go through and execute this, and you can see then our output. So 0 is an even number, 1 is an odd number, and of course 2 is back to being an even number. So getting some good hands-on practice with this is going to be really important. The exam isn't practical, but you're going to have to recognize the code and recognize the results generated by the code.